Hi everyone, I'm Federico, and today with my group I'm going to talk about the exponential decay. We can have two types of exponential function. The first one is the growth and the second one is the decay. The first one has the exponent positive and the second one the exponent is negative. An example of exponential decay is represented by radioactive atoms. In fact, they lost a lot of nucleus particles, and when they have this spontaneous loss, they are emitting radioactivity, and then they become stable. Now, Beatrice is going to talk to you about exponential function formula.
So the exponential function describes the decay of the radioactive atoms amount, that means the quantity. The material half-life is the time atoms need to become half. And an example of the exponential decay function is this formula, that is Qt is equal to Q0 times e to kt, with k less than 0. We know that Q0 is the radioactive material amount when the time is 0, and that Qt is the radioactive material amount at the time t. And we know that k is the constant depending on the decay speed. And now Laura is going to show you an example of this formula.
An example of the exponential decay is the carbon dating. Each living being, so animals, bacteria, plants, is composed by two carbon isotopes, the carbon-12 that is stable and the carbon-14 that is radioactive. When a living being is alive, the relation between the carbon-12 and the carbon-14 is steady, while when a living being is dead, the carbon-12 doesn't change, whereas the carbon-14 decays, turning into nitrogen-14 atoms. So, knowing the relation between the carbon-12 and the carbon-14 half-life, that is about 5,730 years, we can date the living being's death. And now Federico is going to show you the application of the carbon dating in the Shabot cave.
In the Shabot cave, the researchers find a carbon-14 concentration that is equal to 2.4% than the original one. Knowing this concentration and the carbon-14 half-life, we can calculate how long has passed since these paintings were made. Now Giulia explaining you the first part of the problem, and Beatrice the second one.
So, beginning with the exponential decay formula, where we have Qt, that's the radioactive material amount at the time t, Q0, that's the radioactive material amount at the time 0, E, it's a constant, K, it's a constant depending on the decay speed, and T is the time. Now we begin solving the problem, finding the K, that's the constant depending on the decay speed. So, to find the K, we divided the carbon-14 amount by 2, because after 5,730 years, the carbon-14 amount is the half. So, Q of 5,730 is equal to Q0 divided by 2, and knowing that Qt is equal to Q0 times E to kt. For the transitive property, we can rewrite this formula like Q0 divided by 2 equal to Q0 times E to kt. And we know that the time is 5,730 years, so we can rewrite the formula as Q0 divided by 2 equals to Q0 times E 2k times 5,730. So we divide both members by Q0, and we know that 1/2 is equal to E 2k times 5,730. So now we consider the natural logarithm of both members, and we know that natural logarithm of 1/2 is equal to natural logarithm of E 2k times 5,730. So we can rewrite the second member as 5 times k times 5,730 times natural logarithm of E, and knowing that natural logarithm of E is equal to 1, we rewrite the formula as natural logarithm of 1/2 equal to k times 5,730, and so now we divide both members by 5,730, and now we have found k that's equal to natural logarithm of 1/2 divided by 5,730, and so k is equal to negative 0.3012. Now we have found the constant depending on the decay speed, and Beatrice is going to find the time, so she's going to solve the rest of the problem.
So we now find the time when the paintings were made, and we know the constant K and the carbon 14 that the paintings have originally. So we know that 2.4% is equal to 0.024, and we now have 0.024 Q0 is equal to Q0 times E to minus 0.3012 T. So we can divide both members by Q0, and we can consider the natural logarithm. So now we have a natural logarithm of 0.024 that is equal to natural logarithm of E to minus 0.3012 T. And we know that the natural logarithm of E is 1, and we can consider the logarithm property, and so we can write natural logarithm of 0.024 that is equal to minus 0.3012 T. And now we can isolate the T, and we have T is equal to 31,080, and so we have solved the problem. And let's do the exercises.
We have prepared 3 exercises. The first one is the listening. You have to underline the words you will listen during a video. But pay attention because not all the words are said. The second exercise is the vocabulary. You have to match the words in the list A to their synonyms or explanations in the list B. The third exercise is the cloze test. You have to complete a test with the words below. But pay attention because there are 17 words and you have to choose only 10 of them.